I'm Jakub Zavrel from Zeta Alpha, and we're an early adopter of OpenSearch because of the excellent K-nearest neighbor plugin that it had very early on when none of the other Lucene-based search engine had it. So we're into vector search, and I want to talk about fine-tuning. Some people say fine-tuning. Some other people write it as one word. But if you're using semantic embeddings, it shouldn't really matter. So I'm wondering here who has worked with vector search in OpenSearch. We have a few. So I want to hear from you after sharing our experience, what kind of embeddings you use and what you see as the pros and cons of fine-tuning them for a specific domain. So with the large language models, we have obviously gotten this new way of search, which is basically question answering, right? So you throw retrieve documents at an LLM with a prompt, and you get an answer with references back to the original material. And the underlying technology, we've heard a couple of talks this morning, is retrieval augmented generation. And with the advent of retrieval augmented generation, basically search relevance, semantic search relevance has become really important, because if you're going to throw a question at the search engine, you don't want to find a similar question like what is the best way to reduce my AWS costs? Sorry, guys, that is a relevant question in many companies. You don't want to find what is the best way to reduce travel costs, but you want to find something like, here's a report about our monthly spend on cloud. And for that, precision at 5 or precision at 10 is a super important metric, because those passages or documents will be templated into the prompt. And that has really put an emphasis on embeddings quality, right? It's not just the nice trick of vector search, but it's really how good is my top 5 or top 10. And so there's kind of an arms race. This is the MTAP leaderboard that we're watching religiously. Every week there's like a new model. Now the Mistral-based fine-tuned models for retrieval are kind of making their way into the top of this leaderboard. And you see that you should watch the column retrieval all the way at the end. So there's a very large difference between what you can do with like some of the popular embeddings like mini LM or all MPNet and the latest state of the art. But these models are all trained on general web data. And if you have a very specific domain like pharma or legal or e-commerce or whatever, it makes sense to think about fine-tuning them. It's quite easy. It's actually not very compute intensive. You can do it in, let's say, a few hours of compute. And the idea behind fine-tuning is that you move queries and documents that are relevant to each other closer to each other in the space, and non-relevant documents further away from those queries. But in most kind of in-domain data sets, the problem has been that you don't have supervised training data. So we developed this method, which we open sourced, called imparse, which basically, the papers are public. And basically the imparse toolkit uses generative large language models to take your documents, which you always have when you're doing a domain-specific search, and do a few-shot generation of a query, which could be based on that passage. And this gives you data to fine-tune. And basically, our experience is that if you look at some of these use cases, for example, in the chemical domain or in matching CVs and jobs, or in the legal domain, yeah, the difference can be quite large between the baseline, which is a model here, something like mini LM or all MPNet, and especially on many European languages. And by fine-tuning, you can increase your precision at 10 from something like 30% here to almost 80%, adding in some other tricks. So I'd like to hear from you guys what kind of embeddings you are using and what pros and cons you see in fine-tuning.
Do you have any input from the audience? Questions?
I don't think I can really answer your question because I think we need more data scientists in this room and fewer engineers to be doing fine-tuning of your embeddings. But conceptually, it makes sense.
And are you using kind of out-of-the-box embeddings from OpenAI or Pinecone?
Yeah, it feels like where we all are is comparing existing embedding models and trying to figure out which one of those makes the most sense. And you're probably like 2 steps ahead of where most people are, right? We're just still trying to figure out which model is the right one, not even going to the fine tuning. So,
thanks.
Yeah, maybe just to add to what Eric said, I'm also not fine-tuning any models yet, but I also see on your graphs, like the highest gain that you get is from hybrid, maybe not fine-tuning, but just hybrid search, and maybe, using the, your model as a re-ranker, not only as a, like a first-level retriever. So I'm wondering, actually, when it comes to using it as a re-ranker, do you think that fine-tuning versus classic search or text-based retrieval, because your queries are the cases you took were like text, and so how does that architecturally compare?
Great question. So I think you have to do everything you can to. In the context of RAG, precision at 5 or precision at 10 is just the currency of getting trust from your users. And if you do hybrid, for example, using reciprocal rank fusion, actually bad results from your vector retrieval will usually pollute your combined list. So in that sense, if you do hybrid, the combination is kind of as good as the minimum of the 2, is our experience. So they have to be both pretty good in order for the hybrid to contribute. And then you can add re-rankers on top of it.
Do we have one more question for? Uh-oh.
It kind of sounds like what you're saying is it's like garbage in, garbage out, right? And so anything that we can do to make that better is going to help down the way.
Yeah, information retrieval has been around for like 50 years, and at no point in time has measuring your search relevance become more critical to company success.
So, cool. No.